Hello, this is Mrs. Sturgeon here to explain to you how to solve and graph compound inequalities. So what we're going to do is start by solving the compound inequality, and then we'll go ahead and put it on the graph after we've finished solving. So here's the deal. With a compound inequality, there's the solving and the inverse operations that we use for algebra are the same operations. It's just that you have more things that you have to solve for, if that makes sense. So basically, what we're going to do is start just by locating the x. So you'll notice the x is right here. Now, just like we would do in any algebra problem where we're required to solve, we're going to work towards getting x by itself. So notice that in between the two inequality symbols, okay, so I'm just going to kind of separate ourselves. In between the two inequality symbols, you have a -2 associated with that x. So what I'm going to do is the inverse of subtracting 2, which is adding 2. And I don't want to say to do it to both sides because I have now two sides that I have to do this to. So I'm going to put a +2 here. I'm going to put a +2 here. And I'm going to put a +2 all the way over here. So in the middle, -2 and +2, those cancel out. I'm just left with x, okay? The symbols, so the less than symbols, those are just going to carry down exactly the way that we had them, okay? Then we have a 3 + 2. Let's do the math. That's 5. Then we have -4 + 2. Do the math. That's -2. So let's go ahead and put this on the graph. Now, we know that because of the fact that we have this x in the center and our symbols are facing the way that they're facing, we know that this is going to be an and statement. So I'm just going to write that it's going to be an and statement. So because we don't have any or equal to signs in between on our symbols, we're going to go ahead and put an open circle on -2, an open circle on +5, and shade everything in between because it's an and statement. And that's it. Let's go ahead and do another one. So same kind of concept here. We're going to separate it so that down by those inequality symbols, we know that that's where we're going to have to move our numbers away from the x. All right, so if you locate your x, in our compound inequality, rather, it's right here. So I need to be able to move that +1 and that -2 away from the x in order to solve this appropriately. So let's go ahead and start with the +1. I'm going to do the inverse of adding 1, which is subtracting. So let's go -1. And again, we're not doing it from both sides. We're doing it to all of the sides. So we've got a -1 here, a -1 here. And let's go ahead and actually do the math now. -3 minus 1, okay, that's -4. Bring down my less than symbol. Now I've got -2x in the center. Bring down my less than or equal to symbol. 9 minus 1 is 8. Last but not least, I need to go ahead and in front of my x, now I have a -2. Remember, when two things are right next to each other in algebra like this, that means you are multiplying them, so I need to divide in order to get the x by itself. So let's divide everything through by -2. Now, here's the deal, and you can't forget this. Anytime you divide or multiply by a negative with an inequality, you need to flip the sign. So since we're dividing by -2 on all of these sides, we need to flip both of our signs. So let's go ahead and work left to right. So we've got -4 divided by -2. That's a +2. And then I got to flip my sign now, so it's facing the opposite direction. -2 divided by -2 is, well, -2x divided by -2 is just x. And then 8 divided by -2 is a -4. Okay, and don't forget we got to flip both of our signs, so now it becomes a greater than or equal to symbol. So the more proper way to write this is where you have the lesser number on the left side. So I'm going to go -4 is less than or equal to x is less than +2. So same way I graphed before, let's go ahead and put an open circle on the 2. Let's do a closed circle on -4, and it's an and statement, so shade in between. Okay, let's do one more example when we have an or statement. So when you have an or statement, you have two completely separated inequalities, and your job is to solve both of them, again, using inverse algebraic operations. So if you have a minus sign, for example, in this first inequality, I'm going to go ahead and add 5 to both sides to get y by itself. And in our case here, okay, sorry, a couple of technical issues right there. But if I'm adding 5 to both sides here, I'm going to do negative 8 plus 5 is negative 3. So it becomes 3y is less than negative 3. Divide both sides by 3 in order to get y completely alone. We have y is less than negative 3 divided by 3 is negative 1. So I can choose to do one of two things. I can go ahead and I can solve the other inequality and graph them both at the same time, or just graph them one at a time starting now. So I'll just go ahead and graph y is less than negative 1. Let's go ahead and put an open circle on negative 1. All the numbers less than negative 1 are to the left of it. So that's everything over here, negative 2, negative 3, so on and so forth. Because this is an or statement, I know that my arrows are going to be facing opposite directions. So let's go ahead and solve the other side and graph that as well. So let's add 1 to both sides. You get 2y is greater than 6. Divide by 2. Y is greater than 3. So let's go ahead and put an open circle on 3. All the numbers greater than are to the right. And that's how we're going to solve and graph compound inequalities.